Alright, Assalamualaikum. Very good day. This is a e-lecture series for GIM 212 Statistical Methods. If you still remember in our previous e-lecture, I already discussed the analysis of variance, and if you reject H naught for analysis of variance, meaning that you make the conclusion that there are significantly different of mean between the groups that you compare. But now we may be interested to know which groups are significantly different. Okay, then we can proceed with post-hoc tests. And in this lecture, I will focus on Scheffe Test. Okay, but I have to explain actually what is post-hoc test. Okay, so post-hoc tests can only be done when the null hypothesis is rejected. Okay, if you reject the null hypothesis, meaning that the conclusion that you made is there are significantly different of mean between the groups, then maybe you are interested to know which groups are significantly different. Okay, so post-hoc tests can be used to determine which group which mean are different. Okay, there are many types of post-hoc tests. Okay, for example, Tukey, Duncan, Scheffe, Bonferroni. But in this course, GIM 212, I will only discuss Scheffe and also Tukey tests, since these are the most commonly used post-hoc tests. Okay, we start with Scheffe test. Okay, so this test will compare two mean at a time. Okay, you can only compare two means at a time, and you have to list all possible of combination of means, meaning that if you complete the analysis of variance and you reject H naught, and in your analysis of variance, you have three groups. Okay, three groups, meaning that you compare the mean for that three groups. Okay, now you have to list all possible combination, meaning that first you have to compare mean between group 1 and group 2. Then you have to compare mean between group 2 and group 3. And then you have to compare the mean for group 1 and group 3. So this is what this statement means. You have to list all possible of combination of means. So this is the formula for Scheffe test. Okay, Fs is equal to x bar I minus x bar j square divide by MSW, or maybe some textbook use MSE, multiply by 1 over Ni plus 1 over Nj, where x bar I and x bar j are the means of the samples being compared, and I and Nj are the respective sample sizes. Okay. Okay, so this is the first example that we discussed previously in ANOVA. Okay, a researcher wishes to try three different techniques to lower the blood pressure, and then we have three groups. The first one is use medication, the second one exercise, and the third one diet. So at 5% significance level, test the claim that there is no difference among the mean. And previously in our analysis, we reject H naught. Okay, reject H naught, meaning that there are significantly different of mean between these three groups. Okay, now we are interested to know which mean are significantly different. Maybe between medication and exercise, or maybe exercise and diet, or maybe between medication and diet. Okay, so there are three possibilities you have to list, okay, one by one. The first one is between medication and exercise, the second one between exercise and diet, and the third one between medication and diet. Okay, so in previous lecture, okay, we find the mean for the first group, which is 11.8. The mean for the second group is 3.8, and the mean for the third group is 7.6. Okay, so to find the the test statistics, okay, to find the test statistics for Scheffe Test, okay, so this is the formula. Fs is equal to x bar I minus x bar j squared. Okay, divide by, so this is MSW multiplied by 1 over NI plus 1 over NJ. Okay, so now for the first group and the second group. Okay, so this is our first comparison between medication and exercise. Okay, so this is the first comparison between these three groups. So this is actually for the first group, and this is for the second group. So by using the formula, Fs is equal to x bar 1, so for the first group, minus x bar 2, which is for the second group, squared, divide by MSW. So previously, in our previous lecture, MSW for this question is 8.73. Okay, multiply by 1 over N1 plus 1 over N2. Okay, so x bar 1 is equal to 11.8 minus x bar 2 is equal to 3.8. So this square divide by MSW is 8.73 multiply by 1 over N1 is 5 and 1 over N2 is also 5. So now you just have to simplify this, and the test statistics is 18.33. Okay, so this is the first comparison between the first group and the second group. Okay, next we proceed to the second comparison between the second group and the third group. Okay, the second group is exercise versus the third group is diet. So Fs is equal to x bar 2 is for exercise, minus x bar 3 is for diet, square, and all this divide by MSW 8.73 multiply by 1 over N2 plus 1 over N3. Okay, now you just have to substitute all the values that we have. So x bar 2 is equal to 3.8 minus x bar 3 is 7.6, all this square, divide by MSW 8.73, multiply by 1 over. The number of sample for the second group is 5, plus 1 over the number of sample in the third group is also 5. Okay, you just have to simplify, and the answer is 4.14. Okay, next we proceed to the third group. Okay, the third comparison. Okay, the third comparison between the first group and the third group, which is between medication and diet. Okay, so Fs is equal to medication is the first group and diet is the third group. So this is equal to x bar 1 minus x bar 3 square divided by MSW is 8.73 multiplied by 1 over N1 plus 1 over N3. Okay, so this is equal to x bar 1 is 11.8 minus x bar 3 is 7.6 square divided by 8.73 multiplied by 1 over the number of sample in the first group is 5 and the number of sample for the third group is also 5. Okay, so this is equal to 5.05. Okay. So now we already consider all the possible, all the possible combination for comparison, and this is the test statistics that we have. Now we have to compare with the critical value. Okay, so critical value for Scheffe Test denoted by F prime and equal to the number of category K minus 1, the number of category minus 1 multiplied by the critical value from the F distribution in the ANOVA. Okay, so if you still remember for this question, F 0.05 degree of freedom for numerator is 2 and degree of freedom for denominator is 12. So this is equal to 3.89. Okay, meaning that F prime is equal to the number of category minus 1, 3 minus 1, we have 3 groups, multiply by 3.89. So this is equal to 7.78. So this is our critical value. Okay, now we have to compare F prime and also the test statistics, Fs. Okay, now F prime is 7.78. So this is the critical region. Okay, we can only reject. Okay, we can only reject if the test statistics is in the critical region. Okay, 4.14 is somewhere here, meaning that there's no significant difference between exercise and diet. 5.05, okay, 5.05 is also somewhere here, which is there's no significant difference between the mean for medication and also diet. But for this comparison, 18.33, which is in the critical region, meaning that there are significantly different of mean between these two groups. Okay, so the conclusion is X bar 1 and X bar 2 are significantly different. Okay, significantly different. That is between medication and also exercise. Okay, so this is the main reason why ANOVA reject the H0, because there are significantly different of mean between medication and also exercise. Okay, for second example, Okay, for second example, a research organization tests several brands of blender at alpha 0.05. Is there a significant difference in the average price of these three different type of blender? Okay, so in previous lecture, we already find x bar 1, x bar 2, and also x bar 3. Okay, so x bar 1 for this example is 173.6. Mean for the second group is 146.67, and the mean for the third group is 117.6. Okay, and now you still have to compare, you still have to make three comparison, which is between 700 watts and 600 watts. Then second comparison between 700 watts and 500 watts. And the last comparison between 600 watts and 500 watts. Okay, so this is our first group, this is our second group, and this is our third group. Okay, for the first comparison is between x bar 1 and x bar 2. Okay, between the first group and the second group. So Fs is equal to x bar 1 minus x bar 2 squared divided by MSW multiplied by 1 over N1 plus 1 over N2. Okay, so x bar 1 is equal to 173.6 minus x bar 2 is 146.67. All this square divided by MSW. Okay, in this example is 954.59. This is from our previous lecture, yeah. Multiply by 1 over N1. The number of sample in the first group is 5 plus 1 over N2. Okay, the number of sample in the second group is 6. Okay, you just have to simplify this, and the answer is 2.072. Okay, for the second, so this is the first comparison. For the second comparison, you compare the second group with the third group. Okay, between the second group and the third group. So Fs will be x bar 2 minus x bar 3 squared over MSW 1 over N2 plus 1 over N3. So this is equal to x bar 2 is 146.67 minus x bar 3 is 117.6 square. All this divided by MSW is 954.59 multiplied by 1 over the number of sample in the second group. Okay, in the sample, the number of sample in the second group is 6, plus 1 over the number of sample in the third group is 5. So this is equal to 2.414. And the last comparison is between the first group and the third group. Okay, so x bar 1 versus x bar 3. So Fs is equal to x bar 1 minus x bar 3 squared over MSW multiplied by 1 over N1 plus 1 over N3. So this is equal to x bar 1 is 100 73.6 minus x bar 3 is 117.6 square. Divide by MSW is 954.59 multiplied by 1 over 5. 5 is the number of sample in the first group, plus 1 over 5. So this is also the number of sample for the third group. Okay, so this is equal to 8.213. Okay, so we already find the test statistics for each comparison, and now we have to compare with f prime, where f prime is equal to the number of category minus 1 multiplied by the critical value from f distribution. So f 0.05, the degree of freedom for numerator is 2 and the degree of freedom for denominator is 13. So this is equal to 3.81, meaning that f prime will be 3 minus 1 multiplied by 3.81. So this is equal to 7.62. Okay, now we compare the f prime, which is 7.62. This is the critical region where you can reject H0. Okay, you can reject H0 if the test statistics fall in this region. For the first comparison, 2.072 is somewhere here. Okay, it's somewhere here, 2.072, meaning that there are no significant difference for mean between the mean for the first group and also the mean for the third group. Okay, now for the second comparison, 2.414 is somewhere here, 2.414, meaning that there's no significant difference for mean for the second group and the mean for the third group. And for the third comparison, 8.213 is somewhere here, 8.213, meaning that there are significantly different of mean for the first group and also the mean for the third group. Okay, so what we can say is x bar 1 and x bar 3 are significantly different. Okay, meaning that between 700 watts blender with 500 watts blender. Okay, so this is a post-hoc test. Okay, the purpose of post-hoc test is to compare which mean in which group, okay, are significantly different. And we can only proceed with post-hoc test if we reject H0 in ANOVA. Otherwise, there's no point, there's no reason to proceed with post-hoc test. Okay, I think that's all for Scheffe Test. For the next e-lecture, I will focus on the second post-hoc test, which is Tukey test. Okay, that's all for now. Thank you very much. Assalamualaikum.